back to my channel, and today we will explore the part 6 of recurrence relation using linear algebra. Okay, so if you this is the conclusion video to summarize and tell you a short trick which is usually given in the textbooks, but the reason behind it is not explained, which I explained it in the part 1 to 5 of this video series. If you haven't watched the first 5 parts, please you can find those videos in the I tab above. Okay, so let's finally conclude what we learned. Okay, so we were solving this recurrence relation. So what I will do, we were solving this recurrence relation with the initial condition a0 and a1 as 1 and 2. Okay, so whenever you will get a recurrence relation as a question, okay, uh, we will do one thing. We will just copy this recurrence relation with the initial condition in a new page. Yeah, we will add it to a new page. Okay, this was our recurrence relation. Now whenever you get a recurrence relation, the first thing, and these two an minus 1 and an minus 2 are the bases. Okay, or you require these two independent information to get the information for an, and you need to find the closed form, right, of this recurrence relation. So what you do is, first you find the eigenvalues. And how will you find it? Using the characteristic equation. I have explained all those intuition in the previous parts of this series. You can check out in the I tab. So what we will do is, how do we write the A matrix? We will first note the A matrix or the transformation matrix need to be a square matrix. So how many number of bases you have, that many equations you will have to add. Okay, so here we have two bases, so we will add an is equals to 3an minus 1 minus 2an minus 2, and an minus 1 for the previous terms is an minus 1, right? 1 into an minus 1 plus 0 into an minus 2, right? So we will, this becomes the square matrix. Okay, now our A matrix, so we will write it in matrix form. Un is equal to 3 1 minus 2 0 times uh, an minus 2, right, an minus 1, okay, sorry, an minus 1 and an minus 2. Okay, so this is our un minus 1, right? So this become un is equals to, this is a times un minus 1. Now we will find the eigenvalues, the characteristic equation of this matrix A. So that is nothing but, land new page. So 3 1 minus 2 0. Okay, we'll write it a little smaller. 3 minus lambda, then 1 minus 2 0 minus 2 0. Oh, 0 minus lambda, right? A minus lambda I, and this determinant is equal to 0. I explained the intuition in the previous part, you can check out there. So this becomes 3 minus lambda into minus lambda minus 2 into 1, so that will become plus 2, right? So that is becoming, the equation becomes lambda square minus 3 lambda plus 2. This has to be equal to 0. So from here we earlier calculated the characteristic equation was 3 minus 2, lambda minus 2, lambda minus 1 equals to 0, or lambda 1 is 2 and lambda 2 is 1. Okay, these were the eigenvalues. Now note over here, in the previous, when we found out, yeah, over here, okay, so this was S inverse, this was lambda I, and this was S, and this was your U naught, right? So you can see lambda I over here, the lambda I, this can be written as 0 times 1 power n, right? So what you see, a scalar is being multiplied to both the eigenvalues finally. So what is happening finally is your an will look like, it will look like some constant c1 times 2 to the power of n plus a constant c2 times 1 to the power of n, or how many eigenvalues are there you have to add by multiplying some constants. Now how do we get the value of these constants? Okay, so we will use the initial conditions. Okay, we know that a0 is 1, so we'll plug in n is equals to 0. Okay, a0 is equal to 1 and we will put n equals to 0, so we'll get c1, 2 power 0 is 1 plus c2. Okay, we get the first equation over here. Then the second equation is a1 is 2, 2 is equal to we will put n is equals to 1 over here, right? 2c1 plus c2, right? Okay, so if you solve this equation, what you will get is the value of C1, C2, and that will be the closed form of your recurrence relation. So I told you in the textbook, this form of solving reference equation is only given. But if you understand the intuition, you don't need to memorize the formulas of the characteristic equation. That is hard to remember and you might make mistakes. But if you know the intuition, it is easy to solve. Now we will solve for 1 and 2. What we can, yeah, what is the value of C1 and C2? So if we subtract equation 1, equation 2 minus equation 1 we will do. So C2 will get eliminated. Okay. So, okay. So 2 minus 1, we will add a new thing. 2 minus 1 is 1. 2c1 minus c1, so that will be equal to c1. Then c2 will be cancelled out. So c1 is equals to 1. And what is the value of c2? We will plug in the first equation. 1 plus something is 1. So that means c2 is 0. We can see over here. If we put c1 as 1, so 1 plus something is equal to 1. So c2 is 0. c2 is 0, or an is equals to, first eigenvalue was 2 power n and c1 is 1. Plus C2 is 0. 0 into 1 power n. So our closed form nth term is equal to 2 to the power of n. This will generate the whole recurrence relation. So this was to summarize. An exam you can directly solve like this. But if you understand the intuition, then you will appreciate this method more. Okay, please like, share and subscribe to my channel if you find this video interesting and I could explain you something new which you didn't know before, and just be better than you were yesterday. Don't take pressure, enjoy learning and keep looking where discrete mathematics can be applied in your everyday life for and develop problem solving. Keep practicing. Take care. Bye bye.